Assalamualaikum Dr. Syed Najib and Mr. Muhammad Farid. Firstly, allow me to introduce myself. My name is Izzuddin Amirul bin Muhammad Januddin. My project supervisor is Mr. Abdul Wafi and my co-supervisor for this project is Mr. Ahmad Idil. Today, I would like to present about my BDP1 title, which is Estimating the Weight of Mango using Image Processing and Analysis Technique. The content of my presentation today is include an introduction, problem statement, project objective, scope of project, literature review, methodology, initial result, conclusion, and lastly, project planning for the following semester. Next is introduction to this project. One of the most essential fruit produced in Malaysia is mangoes. Mangoes were valued at 126,000 tonnes in 2002, representing 12% share of the total export. For local farmer, this is a high value. Next, post-harvest handling is a crucial step in the fruit production process since it helps maintain its quality. For example, cleaning, grading, and packaging are all part of the post-harvest handling process. Post-harvest takes a quite long time to classify the mango grade. Next, fruit grading is necessary for identify the quality the fruit as well its cost. Many local farmers still heavily rely on human labor to grade their fruit. Following the grade recommendation set out by the Federal Agriculture Marketing Authority of Malaysia (FAMA), the fruit are assessed according to their size, maturity index, and presence of exterior flaw. Lastly, computer vision system may be utilized for automate the fruit inspection and grading and other applications. This system have been extensively employed in the food and agriculture industry for review and evaluation because they offer appreciate speed, economical, concise, and objective assessment method. After this, it is possible that the time taken for the post-harvest process can be reduced. Next, the following are some problem statements for this project. The first problem statement is the size of the mango is one of the most critical factors that customer has identified as being associated with a mango grade. Next, according to the Malaysia Federal Agriculture Marketing Authority (FAMA), the size of the mango is defined by its weight. Furthermore, a computer vision system can help for automate fruit inspection, grading to achieve the mango fruit with the desired weight. Next, difficult to determine the grade of the mango fruit because of the difficulty in collecting the fruit at the proper size. Lastly, manual weighting of the fruit to determine their size is time-consuming, labor-intensive, and expensive. With the help of linear regression approach, it will discover a link between mango pixel and mango weight. Next, there are two objectives for this project to achieve. Firstly, to develop a method for estimating mango weight based on its size using image processing. The operation of processing and analyzing the image is necessary to determine how many pixels are included in the mango area of the obtained image. With the help of linear regression approach, it will discover a link between mango pixel and mango weight. Second, to analyze the performance of the developed method toward conventional method. Manual weighting of the fruit determine their size is time-consuming, labor-intensive, and expensive. Next, the scope of this project is image processing and analysis were performed by filtering and thresholding process using MATLAB software. In this project, we can use other image processing software such as OpenCV library in Python and RoboRealm. MATLAB was used after review the method used from the previous project. Next, image is captured using web camera and transferred to MATLAB software. For example, image acquisition system will support OS generic video interface toolbox. This toolbox was used because this project sent an image from a web camera via USB cable. Next, the position of the mango must remain in static during capturing process. Next, just one mango should be placed at a time. Next, selected mango size between 200 to 500 gram only. These three scopes are very important to cover when performing image processing in this project. Lastly, estimate weight accuracy more than 95%. The accuracy most important for local farmers during grading the mango. Next is chapter 2 about literature review. I have done a literature review of the journal. they are different in the methodology applied to the project. For the problem statement, it is more or less the same as the previous project. For the first paper from Theo and Shafuddin on 2007, the problem statement is a fruit grading industry for identifying fruit quality as well as price. The size, maturity index, and outward fall the fruit was used to evaluate the fruit. For the solution for this problem is the Chakuanan mango picture obtained from image capture equipment was processed and analyzed using computer vision. Next, from Khairul Adila and Sharifah Laili in 2016. For the problem statement is fruit farmer have difficult time harvesting the fruit at the proper size. To solve the problem, image processing, image segmentation, feature extraction and classification were all part of the computer vision approach used in this study. The last paper is from Aung in 2020. The problem statement is many farmers grow various mango varieties to profit and some are high demand for export. To solve this problem, the visible surface area is calculated using curve fitting and the area between the two curves method was implemented in this project. Lastly, the problem statement for these three titles are slightly same. They are is only slightly different in the method that implementation. Next is about previous work. Previous work that I can compare, they are different in the advantage and disadvantage based on the method applied to their project. For positive writer use color camera, but that is different in application software such as OpenCV library and MATLAB. For the first paper from Momin and team, there has one disadvantage for their accuracy were limited, 36 to 79%. Other parameters such as perimeter or roundness can be used in the data point cannot be easily separated. There are different in disadvantage in these two papers. This different result in the possible that the method used is slightly different. Next, this is the methodology flow that was used. They are divided to 5 stages of the milestone. At the first milestone, project objective and scope has been met. Then a literature review is collected, fill it subject within the scope. Next is the second milestone, image acquisition design. In this part, by transmit a wide camera at distance 220 above the plate holding the mangoes, a target item may be located at distance 220 above this platform having the mangoes. It results in a conventional picture size 340 x 480 pixels, covering the whole mango from the above. The specified picture size was selected since a more significant picture size will demand more memory and take longer to process it. Next is the third milestone, that construct an image acquisition system to capture the mango visual characteristic. The term is sometimes believed to refer to the processing and display of mango photograph. Describe it as the process of getting mango picture from a camera, which is often a hardware-based source, because no processing can be done without a picture. This is an initial state to the project workflow sequence. Lastly, when using MATLAB to process photo, create a function file or script file to complete the task. This file provides a document record of the mango processing image used, allowing the outcome to be evaluated. Next is the fourth milestone for the overall process. First way for calculate the actual weight of the mango using the conventional approach. It may implement a linear regression approach between actual weight and the number of pixels of mango. Next, before continue the following process, manually classify the mango by grade A, B, and C, represent large 500 to 600 gram, medium 400 to 500 gram, and small 200 to 300 gram. After that, construct an image acquisition system to capture the mango visual characteristic, because no processing can be done without a picture. This is the initial stage in the project workflow sequence. Next, do the image processing procedure utilizing the MATLAB program. When using the MATLAB to process photo, create a function file or script file to complete the task. Next, find the number of pixels in each mango while doing image processing using MATLAB. This method to employ the pixel value of each mango will be utilized in the following step for creating linear regression between actual weight of the mango and the number of pixels. After that, get the correlation equation from the linear regression graph to determine the estimate weight by substitute the number of pixels into the equation. Next is the last milestone for testing and analysis. Following the value of estimate weight of the mango obtained from the correlation equation, the error between actual weight and estimate weight must be calculated. To establish if our technique is successful, we utilize the root mean square error technique to examine system performance. To obtain a high performance of the system, one method to estimate the weight with more than 95% accuracy. Next is chapter 4, preliminary result. The image on the right shows the mask filter using the color threshold application in MATLAB. Next, the image on the left shows the number of black pixels of mango. For the detailed explanation, I will expand on the demonstration section. This is image acquisition setup for preliminary result at the left picture. At the right picture, the image acquisition setup for more proper in the following semester. This preparation will use low-cost material because our focus in this project for image processing and analysis technique only. Next is demonstration for image acquisition and processing by using Threshold app. Firstly, we need to select the camera that we'll use and take a snapshot the image. After that, by adjust the value of RGB and HSV can get the clear image. Then invert the image to the mask, black pixel and white pixel. Lastly, export the image function into a script file. The image have reached the required threshold. This function will create the value that was set in Threshold app. Next, demonstration for finding number of black pixels. In this method, we need to create an algorithm first. In this algorithm, the image will display from webcam list. After that, preview the image and pause for 2 seconds to snapshot the image. Next, show the image that has been shot. Lastly, the image will process in RGB channel to calculate the number of black pixels of the mango. Next, the conclusion for this project. This section summarizes the process and what was learned throughout the tasks that should be avoided in the future to enhance the project future development. Image processing and analysis method may be used to calculate weight of mango. The finding revealed that using image filtering and image thresholding to smooth and segment mango picture is straightforward and effective method. Next is project planning. This is BDP1 Gantt chart for this project. Next, this is BDP2 Gantt chart for this project. Next, this is list of reference from previous project. Next, this slide to continue for the list of the reference. And this slide also continue for the list of the reference. That is end of my presentation today. Thank you.